So in the previous two videos we've mentioned the word primary key a few times, but we've not really described what it is. A primary key is just a unique identifier within a table. So if you're at school, for example, you may have a student number. If you're in employment, you may have a staff number, and your school or your employer will use that number to actually identify you. Because of course there could be multiple people with the same name, and so your name is not necessarily a unique identifier. In our staff table, the staff number is our unique identifier. We could have two people called Ford who are cooks, but we couldn't have two people with the staff number 6369. In some tables, it's possible to have multiple primary keys. So in our staff training table, both the staff number and the course ID are a primary key together, because we want to make sure that all of the staff only attend each course once. We don't want them to take the same course multiple times. If we did want our staff to be able to take the same course multiple times, we would just not select them as being a primary key. But two columns or more columns can be grouped together to form one primary key. In this example, if we had one member of staff, they could take multiple course IDs, because together they would all be different. But the same staff number with the same course ID would be flagged up as being a duplicate, and would therefore not be allowed to be saved in the database. This is called a composite key, where multiple keys which would otherwise be individual primary keys are joined together to form a single primary key, which are composed of multiple different columns. Now this is an example of the actual SQL codes used to generate the database at the start of this class. As you can see, we've got a few primary keys within each of the actual tables. So we've got the department's primary key, we have the staff number primary key here, we have more throughout. And so when you're creating tables, it's just a matter of adding the words primary key and then the name of the column that you want to add as a primary key in brackets after it. If you wanted to do it a different way, you could change this so that the words primary key but simply after the individual column which you wanted to apply the primary key to, and that would have the exact same result. Both of these methods, however, are not the recommended way to do things. If we want to change this primary key, for example, to add another column to it or to remove the department number as being the primary key, we have to edit or alter the entire table. A much more elegant way to do it is to add the word constraint and then a unique name, so department, and PK, which stands for primary key, department number. And this way we would be able to alter the primary key without actually altering the entire table. So in effect, this primary key does now have its own unique name. In the staff training table, we don't have any primary keys at the moment, so we can add them in. And because we want both the staff number and the course ID to be considered as a single primary key together, we just put them in a single comma separated list. And this is how we do all of our composite keys. It's exactly the same as specifying an individual column as being a primary key. Now something which seems logical when it's said out loud but it's often forgotten is that you can't assign a column to be a primary key until after the primary key or after the column itself has been identified as being a column in the table. So you couldn't put staff number below the constraint. If you did this, the primary key would give you an error when it was trying to be assigned, and then you would be left without any primary key in the table. And as we've already mentioned, there is a naming convention for actually naming your primary keys, which is just the table name and then underscore the letters PK, which obviously stands for primary key. Now, when we were looking at the models, we identified the fact that the department number is displayed in the staff column, in the staff table, but it's not identified as being a foreign key. There's no actual relationship there. It's almost like they're two just identical columns within the same database, and we rely on the actual users to remember the fact that they are linked together. Now we can identify that relationship in code using the foreign key token, which is very similar to the primary key token. A foreign key is simply a primary key in one table which is displayed in another table. So in this instance, the primary key in the department table is the department number, and we're going to display it in the staff table, and so it's the primary key of another table in this table. And so to record the fact that it is a foreign key, we would just type the phrase constraint, and then this table's name, which is staff, and then the originating table's name, which is department, and then underscore FK, which stands for foreign key. The word's foreign key. And then we have the name of the column in this table, which is department number, from here. And we put that in brackets. And then we say references. And then the name of the other table, which is department. And then in brackets, the name of the actual key that it's actually referencing, so department number again. So we're only editing the actual construction files for the table here, but we can use the alt table command to actually enforce this key in our table as it is right now. So that's the code that we had in our other construction file, but we can type alt table staff add, and that will add this constraint if we change that comma to a semicolon. So we can run this now, and as we can see at the bottom, we've added this constraint to our table, and it's telling us that 15 rows have been affected, which is basically the entire population of the staff table. So you can see now, with our staff table, nothing's actually changed. The department numbers are all still here. But if we wanted to try to add a new, or change one of the columns, so we're going to try and change this department number here for the member of staff Ford, who is a cook. We're going to try and change it to 35, but in our actual department table there is no department called department 35, with an ID of department 35 rather, and so we're going to get an error message. We should of course use the staff table, not the departments table. but we're going to get this error message which says that we cannot add or update a child row because a foreign key restraint fails. So because we don't have a department 35, this isn't going to work. If we change it to 40, however, it will work because the department 40 does exist. Department 20 does exist, but that was the original department number. Department 10 exists. But again, if we wanted to assign them to Department 11, we will get an error message. And this is a way to enforce good data within your database. And while throwing out databases isn't really ideal, it's better than having bad data, because at least with good data, you're actually able to perform the tasks as intended. Whereas with bad data, you don't know what's going to be possible. Finally, it's worth mentioning the fact that a column can be both a primary key and a foreign key, or a foreign key and a composite key. Pretty much any combination except for being both a primary key and a composite key is possible within the same table. And the only reason that's not possible is because a primary key and a composite key are both the same thing. A composite key is simply just a primary key with multiple columns, whereas a primary key on its own is just applied to one column.